Okay guys, welcome back. We are starting Unit 2. This is Lesson 1, and this whole lesson will be on strings. Okay, so here we're defining a string. Remember, we have the constants versus the variables. Constants cannot ever be changed while the program is running, but variables can. So if I define this variable called other greeting, and I don't tell Swift that this is a string, but I assign it a string, automatically it gives it that type. Typically we want our strings to be defined as variables because we like to manipulate the strings, especially when we are working with different data that we get from the user, and we manipulate that data. So we know how to print strings, right? We just print other greeting. Here is, they just show you if you want to print lines on, if you want these two lines, right, the question answer, not only did we print it on separate lines, but in your code, you wanted to be on separate lines. One thing that you can do is you can type in 3 quotes and then the data, the string, 3 quotes, and then assign that to the variable joke, or excuse me, the constant joke. So if you want this constant to actually be exactly as you want, how you want it to see on the screen, you can use the 3 quote system. And then here we print joke. So when you print it, it's going to show the 2 lines on separate lines. We can also use different types of escape type characters. Sorry about that. And so, for example, an escape character would be, so the backslash would be in front of anything that you want to tell Swift that this is really, I literally want a quote, or I literally want a backslash, because quotes, as we know, are used to begin a string. So if I were to put a quote here without the backslash, Swift would give you an error, because it thinks that the second that it sees this quote, it thinks that that is the end of your string, right? If you don't put the backslash. So what the backslash does is it says, okay, whatever character comes next, I really want to use that character. I want you to display the quote or do whatever it is. So in this case, we're displaying, it is traditional in programming to print, and then we're going to print hello world in quotes. If you want to use a backslash, you would just have 2 of them. Again, inside a string, a backslash means escape character, but if you really want to see that character, then you have to put the escape character in front of it. Backslash T means tab, to tab over. So if I were to put backslash T right here, it would tab hello world away from print. And backslash R means it's a hard return, so I'm going to, if I put a backslash R here, hello world would show on the next line. So I'm just going to show you here. I've opened String Basics exercise, and I'm not going to do the actual exercise. I'm just going to use this for examples. So let's say that I have a variable called name, and I assign it Smith, and I want to print, so I want to print the name, see what it looks like. And then I'm going to change it. I'm going to say name equals Joe, Joe \R Smith. And let's print that out. That's not a backslash, sorry. No, that's an R, yeah. And then we're going to print name. Okay. So down here you'll see Joe Smith. That's the first print statement. The second print statement is Joe, and then Smith is on the next line. So that's the return. If I change this to a T, then it tabs over, and it looks like it's tabbing over 1. So that's one thing I wanted to see, how many does it tab over? So there's, if I put 2 of them, it looks like it tabbed over 1, 2, 3, 4, 5 spaces. If I put backslash, then it just prints a backslash in between Joe and Smith. Okay, so you get the point. Go back over here. So we have the quotes, backslash, tab, and return. Empty strings is just 2 strings, 2 quotes beside each other will define this myString variable to be an empty string. A lot of times we'll define variables that we're going to use and we assign them an empty string or a 0 if it's an integer or a decimal, because we want to clear out the buffer. If we don't assign something to a variable and we define it, it creates the variable, the compiler, creates it grabs memory space for this variable. Okay, so if I create this variable, Swift is going to go and grab a memory location for my variable. In that memory location, there will be junk, meaning some data that whatever was there before. And then I want to clear out that, that location. I want to clear it out so that there's nothing in it. And so that's why a lot of times you'll see that we initialize integers and decimals to 0. We'll initialize booleans to either true or false, and we initialize strings to empty strings. So the myString variable class contains a property that returns true or false, and I can ask it and I can say, is this string empty? And if it returns true, then it goes in here and it says the string is empty. myString dot is empty. If it returns false, it will not do anything. So this tells us by returning true or false if the string that we're looking at is empty. That's valuable, in many programs. We want to make sure a lot of times when we're entering information into a form, if you've ever entered information into a form, you'll notice that it has a little red asterisk, which means that is required for you to enter. If you leave it blank, if it's empty, then the program wants to know so that it can give you an error and it won't let you go on. So this is something that you can use for that. Characters is another data type that you can use and define. if you do not give it the data type of character to your constant or variable, it automatically creates a string. It defines it as a string data type. So in this example, constant A is defined as a string because we didn't tell it we wanted to be a character. And then B here is defined as a character because we actually told it, hey, we want it to be a character. So character is just another data type. And let's see here. Let me just show you one thing on here. If I define a variable here, var s character equals a var s string. So here I've defined both of them, but I just want you to notice the color, var x int equals 10. So notice that the data types are in purple. These things that are pink are reserved words. So Swift reserves var, which means that you cannot use var as a variable name. You can't use it here, here, here. Let's do that there so I don't get an error. So reserved words, things that are in pink, cannot be used as variables or constant names. Okay. Concatenation. Concatenation is when we attach or put two strings together back to back. So I can concatenate by using the plus symbol. So if I have two strings and I say string 1 plus string 2, it just puts them side by side and it would say hello world. But I do have to have, for example, if I put hello world without the comma and the space, it puts them, it doesn't put the space for me. So I do have to put the space here if I want to be a space there. And then I can also use the plus equal sign if I want to concatenate a hello to my string, I can say my string plus equals hello. So this here gives me hello world. And then now that I have hello world, I'm just adding another hello to the end. Okay. Think about when you're again filling in forms and you fill in a first name and you fill in a last name and you want to print out a report or you want to print it on the screen, you want to print it next to each other, you can concatenate the first and last name and make it nice and pretty. Or maybe you want to concatenate it and save it into a data file, first and last name together. Interpolation means that I'm going to actually use a variable or a constant inside my print statement. So let's just take a look at this for a minute and really dissect it, okay? So I've got a constant name. I have a constant integer. I want to print, it's going to say Rick is 30 years old. So I have the backslash because I'm saying that what I want is I really want the value that's stored in name. I don't want to print the string name. I want the value in name. The way that I do that is by using the backslash with parentheses and putting my variable inside the parentheses. So if I say print x we know that that's going to print 10. If I print X, we know that's going to print the letter X, 10X, that prints the letter X. You see it right here, 10 and X. If I print your number is, and I want to print the number, your number is, so backslash parentheses, X, close parentheses, oh, and then my quote. So now here at the bottom you'll see this is print X, prints the 10, print quote around the X, prints the character X, and here we print the number is 10. Okay, so I've got to put it in the parentheses with the backslash in front of it. It's just a little more complex and it's doing some calculations. So it prints the 4 and it prints the 5 and then it adds A and B. So basically it's just saying, hey, in the parentheses you can add numbers if you want, or you can add variables or constants, or you can just put the variable or constant in there. This here shows us how to compare two strings. Again, this is really useful when we are doing things like checking to see if they've entered the correct answer, right? We want to check, did they enter A, because A is the correct answer, or did they enter their correct password? So we have comparisons to do that. We're going to compare with the same operators that we use to compare numbers. So we can use less than, greater than, equal to, not equal to. Here's equal to, not equal to. And also when we put things in order, when we want to do a sort and we have to put things in A through Z order or 1 to 10, we use greater than or equal to sort things. We don't get into sorting in the intro classes, that's in the advanced courses, but you do get to sort with the greater and less than. So here we have three constants. We have month, and we have the month again, and we have the lowercase month, and then we say if the month equals other month, print they are the same. So we're comparing this one and this one. They're exactly the same. It checks for capitalization. So when you compare strings and characters, a lowercase j and a capital case J is not the same thing. This has to do with ASCII codes. So a computer assigns an ASCII value to each character, and the ASCII value for a capital letter and a lowercase letter is different. Here we say if month is not equal to lowercase month, then they are not the same. So we're looking at this one and this one, they're not equal, so we say they're not the same. Okay. Sometimes we don't really care what if the user enters something capital letter or lowercase letter. For example, if you're asking a yes or no question and you have them type a Y or an N, you don't care if it's a capital Y or N. Or if they type in the month, you don't care if it's lowercase or uppercase. So we have a method that's part of the string class that's called lowercase. So if you have a string and you call the lowercase method, if name.lowercase, what this does is it takes your name and makes it all lowercase. So it changes the capital J to little j and the capital A to little a, but it's not changing it in memory. Name is still going to stay capital J, capital A, because we haven't said name equals blah, blah, blah. We just wanted to change it for a minute while we hold it in memory, compare it to this, and then print this. When we get out of this if statement, the value in the memory location of name never changed, okay? The only way that you can change, well, it's a constant anyway, so I can't change it, but if I wanted to, if it was a variable, I would just say name equals name dot lowercase, and then I do change it permanently as a lowercase name. So again, temporarily it changes it to lowercase, it compares it to this that's changed to lowercase, and then it tells me that the two names are equal. String equality and comparison. Let's see what we're doing here. Okay, so the has prefix method is going to return a Boolean. It's going to return true or false. And what we want to do is we want to say, okay, does the string called greeting, which has hello world in it, does it have the prefix hello? So does it start with hello? Does it end with world exclamation point? Yes. Does it end with capital world exclamation point? No. So again, it is case sensitive. So if you didn't want it to be case sensitive, you would have to change it first to lowercase and then compare it and just type these as lowercase in here. Okay, so again, has prefix, does it start with hello? Has suffix, does it end with world? Capitalization matters. String equality and comparison, finding substring. So does it contain something? So you have these we were looking at the beginning and the end. Here we just want to say, does it have this anywhere in my string? I don't care if it's the beginning, at the end, or the middle. So we're saying if greeting dot contains my name is, notice that my name is in quotes because this is a string, right? This is the substring of that you're looking in here. If that's true, then I'm going to print making an introduction. So contains is a method. Has prefix, has suffix is a method. I would put that in your notes. Lowercase method, you're going to use it. It's really important. I use this one all the time. The next one is going to be count. Count is super, super duper important. So count is going to check the length of your string and return how many characters are in your string. So in the string Ryan Mears, there's 1, 2, 3, 4. I count the space, 5, 6, 7, 8, 9, 10. There's 10 characters. So if I say name dot count and I assign it to here, it assigns 10 to count. Then this is the password, and it's saying if new password, okay, so this is a new password. The new password is 1, 2, 3, 4 characters. If 4 is less than 8, which it is, then we want to tell the user this password is too short. So again, this helps with passwords. This helps with things like names. If you really want a person to enter a name, you might want to say, okay, the name has to be more than one character or something. Or if you're looking for a zip code, right? Zip code has, if you're just looking for the 5-digit zip code, then you're expecting for them to enter 5 numbers. Social security number, you're expecting a certain number of numbers. Student ID, you're expecting a certain number of numbers. So you want to compare to make sure that you have the right numbers, right? I've got 8 or whatever it is you need before you continue. So a lot of times we'll start with getting to see what the count is, and then we'll check other things like if we're checking a password, first let's check the count. Then let's check, did they have special characters and one capital letter? You know, that kind of thing. So you do different checks. So here they're using the switch statement with characters. They have a constant, name some characters. They defined it as E, and then they have case A, E, I, O, U, and then they print backslash some character is a vowel. So E is a vowel. So I enter E. This is true. It goes in here. It prints the E. And then the words or the string is a vowel, period. Unicode are special characters. Unicode is things like emojis. Unicode is maybe characters in other languages. So Swift can handle all of those. And for example, an A with an accent, let's say it's a letter A with an accent in Spanish, will count as one character, just like the letter A in English counts as one character. We're not going to count it as 2 characters just because it has an accent. So here all that we're showing is we're just counting the characters is all we're doing. So we're just showing that even if it's a special character, it's going to be counted as 1. Okay, so that's the end of the strings lesson. In your book, when you read it, your online book, it tells you to look at other methods and properties for the string function. So for example, if I type print name dot and I type in dot, it's going to show me that I can use the append method. So if I have here append, I can read what it does, appends the given characters to the string. This is mirror. A mirror that reflects the string instance. Custom mirror. End index. A lot of index is empty. I think we went over that one, lowercase. So you have, you can remove strings. The remove is actually a good one. For example, if you enter, let's say, a social security number or a phone number, and you actually enter the symbols, you enter the dashes. If you're going to store that social security number in a data file, a lot of times those are not stored with the dashes. Those are just stored, just a string of numbers. 1, to save space, and 2, just to make it clean and consistent. So a lot of times we'll remove characters from those things. So you have remove, remove all, and you can also add characters. If you enter a string like a social security number without the dashes, but you want to display it with the dashes, you want to make it nice and pretty for your report, then you can add dashes into your string. There's the count property. So there are a lot of things that we can do with strings. Your actual program at the end of this unit is going to be manipulating strings. So you'll get to play with that some more and also in your lab. Please email me if you have any questions. Thank you.